quick recap, right? So when we look into the overview, we would see various zones. It could be raw, transformed, a typical use case, right? Once the data is ingested in the raw, then you would have certain transformation, which does the transformation. And you have this information being consumed by various consumers. We could be an app, a reporting application, and could be anything else, right? So in a simplest form, when we look into it, you have a raw where it is one-to-one equivalent to the information what you currently have in source. And then you have the transform where you have data cleanse, you integrated, you create different layers as part of the transformation. And so that that can be further consumed by the downstream application or any specific reporting needs, right? So if we look at from a lakehouse perspective or a different terminology, so you have a bronze where you have the raw ingestion, silver, and then gold, which is an aggregator, which is used by various business used by the business users or downstream consumers, right? When we look into the different zones specific to data, what are the different logical zones, right? Once you have the data, which is coming from various data source, you might land it into your external stage, means an S3, whatever Azure Blob or Google storage. So as part of the data zones, you have various zones, right? So you have raw, you have confirmed, which is equivalent to silver. You could have a reference metadata information, and you have model, which is nothing but the gold one, which is, we could call it as a curated one, which is consumed by the downstream consumer. So work area is where exactly you will persist this information. It could be on a single database across multiple databases, right? And when we say staging area specifically for the information, which is coming as part of your ETL job or any specific process that you use to get the data from a source and do a direct dump, one-to-one copy into the Snowflake. So the other part to this entire flow would be the data consumers and what kind of information they want to look into it, right? So there are challenges when it comes to implementing the logical data zones, right? Some would have data in lake, some would create a warehouse, and do we need a data mart so that it is getting the information from lake and warehouse, right? So different products would have different services that we might need to use to have this data zone being created, right? But Snowflake addresses this problem where it is a single unified platform where you have all the capabilities of data lake, data warehouse. It's a single platform. You don't have to worry about using different services if you're taking your entire workload onto Snowflake, because it supports different workloads, different industry solutions, and the capabilities that this platform provides. So if you look into the typical data engineering implementation, so you have data coming from sources. Part of the ingestion could be you're writing a job which is taking data from these databases, writing it to a stage, and from stage you're moving it to, as part of your ETL, you're moving it to the raw zone, and then it takes the transformation. And once the data is transformed, it is ready to be consumed. So all of these operations that you get to see over here, everything would be done within Snowflake. So there is no data movement out once the information is made available in the raw zone. So if you have multiple zones, you're actually taking your compute to where your data lives. So any computation that's happening within Snowflake, there's no data movement or there's no data which is moving out of Snowflake. Right now, let's look into the main content for this session, right? Data engineering with Snowflake specifically. Eventually, we'll look into the Snowpark, where our entire demo would be on that. So for the data ingestion, what are the other options we have, right? We could have iceberg tables, we have connectors, and for batch data, we use copy of Snowpark. These are the various mechanisms we use apart from the formats that we support for data ingestion, right? To perform data transformation, till probably a year back, most of the users would be using SQL to perform any kind of transformation. But users who are coming from a background of PySpark and to a more specific pandas data frames, right? They wouldn't be very much comfortable or proficient in SQL. Their expertise is in Python. So for users other than SQL, we are providing a new programming or developer framework. We call it as Snowpark, which is specific to Snowflake, where it provides the data frame-like syntax. Those APIs are very much similar to PySpark APIs or Pandas APIs, where you can use that APIs to perform any kind of transformation on the data, which could be in your external storage or which is there in the Snowflake tables as such. So how do you orchestrate everything? You have written a job and you want to orchestrate be it your machine learning model, be it your data engineering pipeline, you want to run it in a scheduled interval. You have streams and tasks which takes care of it. So apart from any other orchestration tool that you're using, if you want to move out of any third-party orchestration tools or any specific product, a native task is something that you can make to it. Using streams, you get to use the features of change data capture, where you can take the new incoming data and start working on the data. So if I want to run the entire pipeline and orchestrate, there needs to be a single entity. So you can wrap your entire data engineering pipeline or your machine learning training in a single stored procedure. This could be a Python-based stored procedure. You're writing anything Python, or you're writing your data engineering pipelines very specific to Scala. Then you can create Scala stored procedures and Java as well. So you wrap it in the stored procedure and you execute it on the server table on your Snowflake server side. So dynamic tables are something very new, where that will help you to create a specific kind of table. That is, you can write a declarative query which get automatically refreshed and this table gets updated. So you don't have to worry about how do I update. So it could be joins between a fact and your dimension, and you want to create a new fact, or between staging and a dimension table, and you want to create a new fact. So you could create a dynamic table where as and when the data comes in, it does a periodic refresh for you and supports complex various aggregations, various joins, which is not supported as of today in materialized view. So it's an enhancement to that capability, right? From pipeline experience, if you want to monitor your data engineering pipeline as such, right? What are because creating one, but you have to ensure it is running seamlessly and you have various checks and balances to get alerted, and there's a notification comes in when an event happens. Could pipeline complete, pipeline fail, or any of these, right? So you have alerts and notifications natively in Snowflake that you can make use of it. You have task viewer to figure out what are the status of my task, when was it last executed, give a history of tasks over last 10 days and all. Right, and with replication, a new feature which has came in, where if your database gets failed over because of a catastrophic failure or because of any planned maintenance, then you have your tasks and ingestion framework pipelines getting replicated as well. So you don't have to worry about recreating your tasks on the new replica when the failover happens. Let's look into the Snowpark for Python. So what Snowpark is, right? Snowpark is a new developer framework for Snowflake. So basically, it allows, I would say, any data. Since this session is specific for data engineers, I would emphasize more on the data engineer. So any developer coming from PySpark background, be it a data frame, working heavily on Pandas data frame. So this particular feature is specifically for you, to be more precise, right? Where you get to see the same APIs, be it the data frame style querying that you use in PySpark or Pandas. This is very much similar when you start working with Snowpark. So a simple example, if I want to read a file, I would say like session.read.csv, read.parquet. I could do the transformations whose syntax is very much similar to that of your PySpark, or to be more precise, Pandas. So how do we get started with Snowpark? Snowpark has two components. One is the client side. That is on your local machine. You just install a library, after which you can use all the Snowpark specific native data frame APIs. So since the style of programming is natively to the data frame style programming, it's not just confined to one language. You have support for various languages. If you're using Scala specifically, you can use those APIs as specific for Scala, and as well as Java. So apart from SQL, you have different languages that you can use to use the Snowpark feature. On the server side, since this is because you have to have an interpreter runtime on the server side. On the server side, we have various runtimes to support these different languages, be it Python, Java, and Scala. So basically, what we are saying is you do the development locally on your server, locally on your box, to be more precise. And then once you have identified this is what the output where I want to run this periodically on a scheduled interval, you can just deploy, wrap it in an object, and run it on the server. So by which you're taking the compute to where your data lives. For compute, it's not the other way around where you're taking the data where compute lives. So both your compute and your data is happening within the Snowflake. Right, so what all do we have specifically for Snowpark for Python features, right? On the client side API, as I said, the syntax is very much similar to that of data frame. So you have Snowpark native data frame APIs that you can use to perform the transformation. The way, example, you would have used SQL queries, but you want to do it differently by using native data frame API. So probably your team is comfortable with Python, very comfortable with PySpark or Pandas, right? It's easy for them to get onboarded where they write queries which are very similar to what they have been writing in the other products or platform. So you can run your entire code locally. Once that particular code is tested locally, then we'll see how do we take it forward, right? So other next step, once you have tested the code locally, now you have identified that you have a custom code as well, custom Python code that you want to use it as part of your entire framework. So you can wrap your custom Python code, and taking an example, it's a scalar which does a calculation and gives a scalar output. So that's a custom Python code. There's no Snowpark or Pandas or PySpark API, a core custom Python code. So I can take that code, wrap it in a user-defined function that becomes an object in Snowflake. So I can call that particular user-defined function using SQL queries, or even I can use it using my data frame APIs as well. So I can use that for my for the columns on which I want to use these functions. Vectorized UDF is great if you want to improve the performance of the UDFs where you want to give the data frame as an input. That works really well. That would tremendously improve the performance where you're not worried about row by row. You're okay if a bunch of rows are taken together and being processed. So vectorized UDF is a great use case. User-defined table function, you want to give a table value as an output. That this helps you to do that. And more importantly, the stored procedures, right? So Python stored procedures, as I said, you can wrap your entire data engineering pipeline inside a stored procedure, and you can execute it using tasks or any like an ADF invoking any specific stored procedure and whatnot, right? You can use any orchestration tool which supports Snowflake objects. Pretty much you can invoke, this becomes an object in the Snowflake. So it's pretty easy, seamlessly gets integrated with other orchestration tools which already support Snowflake. And eventually you can get rid of those third-party tools by running these natively within Snowflake by using tasks. Right. So why do we need Snowpark? Is because it's a single platform. It supports various languages of the choice. We're not confined just to SQL or a Python. You have Scala, you have Java. So we are allowing different developers with different skill sets and programming experience to easily get onboarded and start working on the Snowflake data. So scalable pipelines, you can build out pipelines because of the features what Snowflake platform offers in terms of scalability and elasticity. You can ensure that your pipelines are not confined by any compute restrictions and not even the amount of data that you store. And more importantly, everything that you keep in Snowflake is governed. You have the same enterprise security and governance across all the objects that you create. So it doesn't treat Snowpark any different, because you have to wrap it in a stored procedure and execute. So you could execute a Snowpark code using a Java, Scala, or Python. The consistency in terms of the governance and enterprise grade security what Snowflake offers would be applicable to everything that comes in for Snowpark as well. To be more precise, any object within Snowflake would have those inherited by default. Right. So when we look into the Snowpark for Python, you have, as I said, the programming constructs are very similar to that of Pandas data frame or PySpark. So people who are working on this, they will find it very similar. And with minor changes, they can migrate their workload from Spark to Snowpark, right? Anaconda, what we have done is, in order to handle the issues with respect to dependencies, if I'm installing any third-party libraries, using pip, there are always issues where they are missing dependencies. You'll get to know when the code is getting executed on the server side or if you're deploying it to some other location. So to handle all these issues, Snowflake has integrated with Anaconda, where you have a secured repository or secure channel specific for all the libraries, which can be made available on Snowflake for your code to get executed. So you have access to a lot of open source libraries, which comes pre-built as part of your Anaconda repository. And secure processing, we'll talk more about it, what processing is. So in order for the Python code to get executed on the server side, what Snowflake does is it spins up a secure sandbox. Assume this sandbox could be a VM or it could be a container, anything. It's a box which is hosted right inside your virtual warehouse. So it is not hosted anywhere outside your virtual warehouse. You don't have to spin up anything. The moment you call your Python function or your Python stored procedure, sandbox is provisioned for you, and it ensures that your code is securely executed on the sandbox, and it has all the governance and capability where you are ensuring you have all the packages that you need for your code being already pre-installed on the server side. So if you're using a scikit-learn as an example, or you're using GeoPandas for an example, all you have to do is call stating, I need this package. You don't have to install anything on the server side. When you execute locally, you do pip install or conda install, you have certain packages, you're doing a local development. You want to take it forward onto the server side, all you do is wrap it in either of the, based on whether it's a function or UDF, execute it on the server side by specifying the package name. On the server side, on the sandbox, Snowflake ensures those packages are pre-installed or gets installed based upon the call, and your code gets executed without any issues or having issues with the dependencies, right? So when you execute, what happens when you execute a query, right? So if I'm firing a statement, a df.filter, a, for a specific, a typical API style, right? Data frame API style. So behind on the, you have a Snowpark client-side library, which takes your data frame APIs using a query translator. It converts your code to SQL query. And this SQL query is pushed down onto the Snowflake engine, and using the performance and the elasticity capability what Snowflake provides, this SQL queries are executed natively inside your warehouse that you provision for your account. So all your data frame APIs gets converted into SQL, and the SQL has been pushed out onto the Snowflake compute where it gets executed, and it's distributed across the number of nodes that you spin up for your warehouse. When it comes to Python UDF, when you execute any custom code, custom Python code, Snowflake, it ensures that it serializes that particular code into Python bytecode, pushes down the Python bytecode onto the secure sandbox, that Snowflake is spinning it for everyone. And end users, developers don't have to worry about how do I create the sandbox. It is everything taken care by Snowflake. No user action is required. So this Python bytecode is deserialized and gets executed on the sandbox. Since it has integration with Anaconda, based upon the packages that the code needs, it ensures that all these packages are pre-installed on the secure sandbox using virtual environments, what it creates for every execution of the code. So probably I'll take a minute before I get started with the demo. Any questions in terms of the Snowpark and what Snowpark is bringing in for the developers?
Yeah, funny. There is a question, interesting one, which asks about, does Snowpark use Spark in the background?
No.
Yeah.
Snowpark is not using Spark in any way, because as I said, when we look into the this specific slide, the name is Snowpark, so probably we're thinking is Spark involved in any way. It's not using Spark for anything. All your compute, as I said, a simple example, any data frame APIs that you're trying to run, it gets converted into SQL queries behind the scene. And those SQL queries are pushed down onto Snowflake. And that's where it gets executed and distributed across multiple computes that you are spinning up for a particular warehouse.
Another interesting question, Funny, is that do we do any lazy evaluation of any external files? So of any external files on S3. So the file is on S3, and do we do any kind of evaluation on top of it? Was the question.
Yeah, exactly. No matter where it is, it uses the same concepts. If you're coming from Spark background, it uses the lazy evaluation concept where you have actions and transformations. Any transformations that you're performing will not be executed until you have an action associated with it. You're reading a file, doing aggregations, group by, nothing gets executed until you say write to a table or say show a few records, create a view or something on those lines. When you're trying to do only then the code is getting, or the action actually happens. A transformation is actually executed, to be more precise.
Sure. Funny, please continue with your demo.
Awesome.
I'll keep you posted on other interesting questions.
Sure. Thanks, Sarita. So this is extending to what Sarita has already demonstrated in the last session. We're taking halfway from where she left, and the other part where Snowpark is involved for the transformation is something we'll look into it. But for those who haven't joined, I'll do a quick recap of what this demo is all about, right? It's basically a Tasty Bites, a food truck where you have orders coming in, it's ensuring that the good food is being served to the customers, and the local chefs or basically the restaurants are given preferences. So there are a lot of trucks across different locations, and where you have these services in different areas, and it's serving or basically delivering food wherever it is needed. So there are future goals in the current state where they want to increase the number of franchises, number of trucks. So if we look into the overall the end-to-end scenario, right, for data engineering pipelines, this is pretty much what we are trying to do. We have data for POS, we have customer data which is coming in. It's already there in our S3 bucket. So what we have done is we have created an external table, which is already covered as part of the demo in the earlier session. So we are just creating external tables, which is querying the Parquet files, which is on my external storage. And apart from that, we are getting the data from marketplace. So this could be a great use case where you want to use any specific data set, which is there in Snowflake's marketplace, and you want to join it with your data, because that's a live data. So we don't only copy, but you get real-time data whenever the source or the provider is updating the data. In this case, we're using the weather source information, which has got postal codes and the weather day information. So we are taking that information, and then we are creating multiple tables over here. As you can see, these are the different tables. So this order and order header has data for 3 years. We have 2019, 2021 data. And this has the other information like country, franchisees, and the truck data. So basically, if you're part of the previous session, right, you would have seen where you have data created, specific jobs which would have run to populate these information. So you would have seen some part of the Snowpark over there. But we'll see what happens next, right? So how do we take this raw data and create an harmonized layer where I'm creating a view which is joining data across multiple these tables, and then eventually again create a user-defined, probably one way is to create a user-defined function. What I'm doing is I'm getting Fahrenheit, I want to convert as a Celsius, that's how I want to store it. So I'm creating a custom Python function, and we'll see how do we wrap it as a user-defined function and invoke it as part of your data frame APIs, right? And then the entire orchestration, I have my data engineering pipeline. Now I want to wrap it in an object so that I can execute it on a schedule interval. We'll see how do we wrap it in a stored procedure. So we have this information coming from orders, we have coming information from our raw data, and that's where we would use this information to populate something called as orders table. Then eventually, once this is done, as part of the analytics, we want to create a daily city metrics where we are getting information from our marketplace data, as well as the orders data that we have created over here. And basically, we are using sources, data from different sources, that is marketplace, our own generated data, and we are populating a specific table which is used for analytics. Could be used for reporting, a Streamlit app, or anything. So how do we populate it? Is we write a data frame API pipeline, wrap it in a stored procedure, and execute these stored procedures as part of the task. Now, once we have this, the important question is that I am a Snowpark code. How do I deploy this Snowpark code as part of my CI/CD to various accounts or different accounts? If a user checks it in, and I want to automate the process where it takes the code which is checked in to a specific branch, and then push those changes to the required Snowflake account. Right. So going back to the demo, let's go to the demo. Okay. So we have seen information till the step 3. So let me go back. What do I mean by step 3? Is we have populated this information as part of the. If I quickly, I'll take a minute to showcase, what exactly we are doing. Right. This entire thing is we are using Visual Studio Code to specifically run our Snowpark jobs or Snowpark data frame APIs, or to be more precise, your entire data engineering pipeline and transformation, we are running it in Visual Studio. So we have a specific extension for Snowflake as well, where you can run SQL queries, or example, as you could see, if I look into any of these queries, probably I'll see if I have any queries. Yeah, this one, right? I'll minimize this. So basically, I can run this, you have an extension, marketplace extension, where you can go ahead and install that particular extension. So if I go and say Snowflake, so this is an extension what you have. You can go ahead and execute. Once you have it, all you have to do is specify the connection details, and you're good to go. You can execute your SQL queries as well as your Python code using the same ID. So going back, we have loaded this data. As you can see, we have created a stage, and as part of the raw data, which already Sanita has covered, but this is just a quick overview for the folks who are joining. So what we are doing is we are using Python code using data frame APIs. Specifically, all you could do is session.sql. Anything is, you can, the way you do it in Spark, it could be PySpark. You could do like spark.sql and you could write a query. Similarly, session is equivalent to assume a Spark context. Session points to an instance for your Snowflake account. So you're saying this session maps to the Snowflake account, and to be more precise, to a table and to a database, right? So I can do whatever operations I want to do as part of my data frame APIs. So here we are doing pretty straightforward. I'll talk more about transformations that we can perform, but pretty much we are just taking multi-year data and we are dumping it into different tables, as well as weather is nothing but a marketplace data which we already have it. It's part of the marketplace. We go and get the marketplace data, which is with what Snowflake offers. Right now, let's look into the one of the areas. So if I go back to this one, step 4 is I'm creating this POS flattened view, which is nothing but joining multiple tables and whatnot. Right? It's creating a view at the end of the day. So how do I do it? So let's quickly walk through. So what we are doing is we are getting a session context. Session, as I said, is just an instance. We are saying, okay, this is an instance for this particular account. It has got details about to which account. If I'm creating a table, this session tells me that, okay, this is an account, this is the DB, this is a user who needs to go ahead and create a table or create a view. If I want to read a table from Snowflake database, the session would help me whether I have privileges or not. So using this session context, I would have access to anything which is in Snowflake, or eventually anything which is even in external storage. If I want to read a file, I could do the way it's been shown over here. So if I want to read a Parquet file, I'm saying session.read Parquet. This is the location, which is an S3. We are creating a stage on top of the S3 and pretty much reading the Parquet files, which is in my S3 bucket. Right here, what we're doing is, as I've already created, just to save some time. So pretty much all you do is, if you see over here, once as part of this view, we are actually joining multiple tables. So all we're trying to showcase is how you can read different tables from Snowflake, do a selective columns, fetch selective columns, which is needed for the part of transformation. And eventually we'll see how do we join these tables and all, right? So as you can see, we'll just do session.table, or you could even write session.sql. You could even put select columns. So what I'm trying to say is you can put session.sql and write a SQL query. But people who want to use true data frame API style, then this is pretty much what you can do, right? Session.table, and you can specify what columns do you need as part of this data frame. So we are doing it for details. This is all from the raw zone that got populated as part of the previous step. We are just fetching this information. Same is with order header. I'm saying select all the columns I need. Similarly, I'm just looking at multiple tables where I need the required columns. And next step, once we identify this, we'll see how do we join these tables across using inner join or any kind of join, right? So I'm saying truck, I'm joining with franchisees based upon the column. So as you can see, looking at the syntax, people who are already working with PySpark and Pandas, right? You would see the syntax is very much similar to that of you've been using. So suffix, these are very specific, where if you have a common columns, then it adds a suffix to the common columns which are common across two tables. When you say R suffix, your right side table, if let's say franchisees are common, so you would see a column called as franchisees ID. Also, you would see a column called as franchisees ID _ F. So it says, okay, right side column, right side table, the column which are same across both the tables would have a suffix added. Even you could add L suffix. You want to add at the left table columns to be suffixed with something else, you can even do that. So again, we are joining, as you can see, we'll be joining with multiple tables. Joining to data frame, it creates a data frame at the end. Yeah. So when you're doing anything, right? If I'm doing session.table, so it is creating a Snowpark data frame for me. The way you have PySpark data frame, you have Pandas data frame, you would see something called a Snowpark data frame. Very, very similar. You could do session.table, everything. Either you do session.table, session.sql, anything. The output is a data frame. And this is nothing gets executed since there is no action. All these are transformation. So it's a lazy evaluation process where nothing gets executed until you perform any action. So when you run this and when you execute this, you wouldn't see Snowflake or Snowpark taking time to execute because it hasn't done or it hasn't executed anything behind the scene. So eventually, when you look into it, I'm joining multiple data frames, order ahead, join with the different data frames on different columns and whatnot, right? And at the end of the day, I have a final data frame, and I want to ensure I'm selecting the columns which I need as part of my final data frame. And all I do is there's a data frame function. The function what data frame provides is create or replace view. Even it's a single word as well. There you have different functions which does the same thing. I could even use just create or replace view, a single word, the way it is there in PySpark. It's going to be same, and I'm specifying the location. And this is since the session object already is aware of which account, which database, all I need to provide is either the table name, or I can provide schema name dot table name. So if I execute this code, you would see, let's go and check what's there in Snowflake. I've already executed this step. For the next steps, I'll showcase how do we do it. I'll go to this and just have it. One second, let me create. So this is the view what was created as part of it. So I can look at the definition for this view as well. Let me zoom it further. If I look into the definition, this is pretty much what it has created. So as you can see, this is a view, and it gives you the definitions. Because as I said, your queries are converted, your data frame API gets converted into SQL queries. So this is how, when we are trying to understand how exactly a view would be created from a data frame, right? So at the end of the day, we're just joining multiple tables. So this is what the join looks like. So when you look into it, you don't have to worry about writing SQL. If you're comfortable with data frame APIs, you can pretty much use that. And behind the scene, it ensures that it generates an optimized query for you, which gets executed on the server whenever you're inputting it. Right, as you can see, this is pretty much the output, what it looks when you execute it from there. So you have seen that how your data frame API gets converted into a SQL statement. You could create a table as well, or take an output, dump it, or in this case, view. We have created view just to showcase, what the output would look like and what the definition would look like when you're converting your data frame APIs into SQL, which you don't have to do it. Snowflake behind the scene does it for you. Okay, now the next part is I want to create a user-defined function, right? A typical scenario. So all I'm doing over here, as you can see, let me comment this for our other stuff. Okay, so all we are doing is we are just taking some input and we are executing, right? There's nothing fancy over here. If I really want to see that, if I just give 35, it gives me some output, right? I've written a Python code. I'm comfortable. I know it's giving me the right output. So how do I wrap it in stored procedure, right? I want to take this code and create a stored procedure. So one way is you could use a feature called a Snow CLI that helps you to take your Python code and wrap it either as a user-defined function or a stored procedure. We'll see it's very simple. You say Snow function and you just do create. So what all do we need is we just need to add a file called as .toml and requirement.txt where you say, okay, I am dependent on ABC libraries which are part of my Python. So all I just need to include the way you do it, you do a pip freeze and get the requirement.txt. Use the way you have it in virtual environment, you freeze your virtual environment, get the requirements. And you create a new file called UML where you specify the credentials to which object, where exactly you want to create this object. So where do you want to deploy or create a user-defined function, right? And some of the default parameters, like it takes an input as a float. It gives you a written, what do you want to zip your entire Python code? You want a specific name for your zip file? Because as I said, when you want to run your custom code on a server, it zips your entire code and ensures that it converts into bytecode, runs it onto the server and deserializes and runs on the secure sandbox. So you want to zip your entire Python code, which automatically is done by Snowflake, or you can using Snow CLI, or you can do it by in a different way, which I'll show it as part of our stored procedure as well, right? Whenever I want to execute this function or this module, what is the main function name which needs to be invoked? That is where we specify handler. Handler says, okay, this is my module name, and which function do I want to execute whenever I'm running this code? So we are saying execute the main one, and that's pretty much right. This is connection string, which already has been covered. These are very basic. It's like copy paste across multiple objects you're trying to deploy. Only thing that changes is the input parameters and the environment where you want to create it. So the moment I say, let's see where it is creating in the analytics, first go to the Snow side. And let's see, do we have any function? So this is a different function, right? This is an existing function, but we don't have any different function over here. So let's is the font, let me clear it out and I hope it's much clear. I do Snow function, I do create. So it's looking for all the dependencies which are part of my requirement.txt and does creates a function for you. It takes like a few seconds for the function. So all the requirement.txt, it creates an app.zip, which takes it, and we'll look into how exactly a Python function would look like is something we'll see after this is created. So very, very simple approach. And by the meantime, I guess we have another Python function which is available. Now, this is a SQL function. Just a quick difference, right? For the folks who are just looking into it, this is pretty much we say language as SQL, and I'm just running a simple a logic where it takes an input and multiplies by a number. This is what we get to see as a SQL, but it is done. Let's go back and see what our Python user-defined function looks like. Yeah. So this is how it creates for you. So it's taking your entire code and it's just wrapping it in a particular zip file. So since it becomes an object, right? If I want to call this guy, all I have to do is I can just call it as any other thing. I already have it over here. For the first time, since because we are spinning up a virtual environment, it takes some time, but eventually subsequent execution for any subsequent function call, it is pretty very, very fast because the virtual environment is already created for you. It is taken care. As you can see, this is pretty fun. If I just re-execute it, it hardly takes any time. So this is how you can create take your Python code, create a user-defined function, and invoke the user-defined function even in your data frame APIs or as part of your simple SQL queries, and you want to call this function, you can do it. But behind the scene, it's invoking a Python code to you. So if we see something over here, I just want to showcase, right, how do we know a Python environment and all, right? So if you look into the profile, you have something. So you have something called as Python environment created. So this for the first time, if you're running it for the first time on a warehouse, it takes some time, probably a few seconds. So most of the time is spent over there for a warehouse. But once it's created, this time is significantly lower. It is as good as assuming you're creating a virtual environment, which takes hardly milliseconds. So it's the same amount of time where it takes, and that's great. So it's clearly giving you an indication that this is the Python code where the amount of data which is sent to this code for this Python code is taking and giving the output for you. So let me go back, and we've seen. So the next step, let's look into the slides and see what's the next step, right? So we have created this function which is doing whatever is needed. Now we'll see how do we create a stored procedure, right? Which is running your entire pipeline transformation. Could be a large complex transformation. So we'll go back to another step. First, what will I do is this will take, first let me create it the way it is very similar, the way we have created, and then I'll talk about what exactly is happening in that, because by the time it gets executed, the function gets executed, we are spending time on looking what the code is doing. So it's the same thing. I'll quickly show you what this is. So it is doing a lot of transformation, right? So it is getting data, it is running merge and whatnot. We'll deep dive what this code is doing. But similar to the way we have created function, right? We'll specify certain details about what the input parameter for the stored procedure is, what is an output, where exactly we want to create this particular virtual stored procedure, right? In this case, I have an app. So you could see this is a typical pipeline which is transforming data, and eventually it can write into a table, right? That is what you will be doing it, where you're taking from raw to silver, silver to bronze, or raw to transform to curated and whatnot, right? You're not giving any output. You're taking input data set, transforming, writing to another table. So pretty much we are doing it as part of our API. But once I have this Python code I've tested locally, all I'm doing is taking this Python code and running it on, wrapping it in a stored procedure and running it. So if I look over here, so we have certain files. This is not needed. This is created, so I would delete it. But requirements for txt is pretty much what libraries you need, right? We are using same thing. I do snow create. Snow procedure create. So if you look into this file, so it's basically, it will create a stored procedure with this name, because this is the name what you have specified over here. So it ensures that your entire code is wrapped up into a zip file. And this is the name of the Python stored procedure, which will be created in Snowflake. Okay. So I'll do is, all I have to do is I have to just invoke this particular stored procedure, and it would be done. So there are two ways to call it. Once a stored procedure is created, right? We have seen for a function, how do we do it is we have seen we are going to snow site to demonstrate. I'll do a call and the function name. Even using the Snow CLI, this is a library which helps you to create stored procedures, run stored procedures, and eventually deploy it as part of your CI/CD, right? You can have your DevOps pipeline invoking it. So you can even use Snow CLI to even execute your code. You don't have to go to Snow site and do things. So let's go and check what is created in. Let me see what in which. So it is created in the harmonized layer, harmonized schema. As you can see, this is the SP. Let's look at the definition, right? How it looks like a Python user-defined, a Python stored procedure. So as you can see, it has taken everything for you. If you have more dependencies of the packages, you can just include, if you have scikit-learn, if you have any pandas dependencies, numpy, all you can just put it as part of your requirement.txt. That would by default, you are not installing anything. So these packages are part of the Anaconda channel, which is made available. There's a specific secure channel for Snowpark in the Anaconda channel, where you have all the packages that are listed, which says, okay, these are the packages which can be easily installed on the sandbox. You don't have to do anything. But if it's not listed as part of those Anaconda channel, then you have to custom import it the way we are doing it over here, right? You would take your entire custom code and put it over here. Now let's see how this looks like, right? If I want to do snow I could say this is what we are doing here is we are just, instead of using call, we are actually showcasing, how I can use Snow CLI to actually execute the stored procedure. So this is pretty much, it goes run. Now let's go ahead and understand what the code is doing, right? I'm not using any Snow site. I'm not using Snowpark. This is one AL. If you've used any other like Azure CLIs or any other CLIs, right? Similar to that, we have Snow CLI. Here we are creating a stored procedure using a Python code, and we are showcasing how you can use Snow CLI to in fact execute the stored procedure as well. So let me go back to the code, right? What exactly is this code doing? It will take like few minutes, 2 to 3 minutes, because it does. The volume is huge in millions. So we'll see what we are doing. So the only requirement, right, for your entire Python code to be make it eligible so that it runs on Snowpark is you have to add a specific parameter. That parameter is nothing but the session parameter. The session, as I said, it's an instance or an entry to the Snowflake. So we are saying any argument, let's say your code, your Python code or a function has 5 parameters. You need to ensure your first parameter is always session. And you can include the other parameters which are used in your code after session. You can't put the session as somewhere at the end or in between. Ensure your first parameter by default is a session, by which it understands this is the code I need to execute, and this can be converted into, or it can get executed on the server side, and it understands, okay, this is something which I need to run it on the sandbox. Right. All I'm doing is invoking the main method as part of it, taking the session, passing the session. And this session is not required on the server side because that is where you are executing, right? So you don't have to worry. For locally to run and test, you need the session. But eventually it is not, you don't create, okay, you don't provide the connection string of the session to which account when you're running it on the server, because it understands that session points to the account where you're running the code itself. Okay, so let's look at what this is doing, right? So we are just ensuring some checks and balances in terms of the table exists or not. We are creating a table, permanent table, using the view that we have created as part of the step 4, right? The flattened view, which is joining, we have seen the code, how it runs. And in order for any action to happen, I need to use collect. You would have seen that if you are coming from Spark background, it is very similar, right? So I'm calling a collect function, which becomes an action for your transformation to get executed on the server side. On the server side here, I'm saying HD Snowflake. I'm just adding a new column. This is just to showcase you can write your SQL statements as well. It's not just confined to data frame APIs. The way you write any SQL statement, take that and wrap it in session.sql. Next is we are looking into, once the table is created, we are creating a stream. Stream is nothing but kind of assume it's CDC, right? New data comes into the system. It only shows you the incremental data, which was inserted as part of your, let's say from raw to silver zone, and you want to track what new information came in as of today. You can create stream on a view. You can create a stream on a table that helps you to get only the incremental data which came in as part of your load. So once we even create a stream, then that's where we are looking into the merge option. So here we are using typical merge. It could be the Spark merge that you might have used it. Very similar to that. All we are saying is what is the source. Source in this case is nothing but the stream, and which is assume it's a table by itself, right? Which is only looking at the new records for a particular table. And this is we have created a stream on a view called as POS flattened view that we had seen in the last step 4, how we have created that view. I'm creating a stream on a top of view. That's the beauty of Snowflake, right? Where you don't have to worry about identify what is the ETL, create a config table, look into what is the ETL timestamp, get me on. You can easily remove those pieces of code and just create a stream that helps you to give you incremental data. So pretty much it does these operation metadata columns. I'm saying these are the columns, some updates, and typically running the merge, right? If it exists, I want to update the columns, and the columns is nothing. We have using comprehension, right? Dictionary comprehension to create a key value pair in this case. And we are updating the columns when not matched in a typical merge syntax. Or else you can write session.sql, people coming from SQL background, they can write the merge queries, merge, the syntax that you use it for SQL. And the amazing part is I can scale up my data warehouse dynamically for that piece of code to execute. As we have seen, we are just changing the warehouse size from small to an extra large because we think this will take time. This happens within a few seconds, and I run my code, I'll scale it down. So this is instantaneous. They are not impacting the other queries which are getting executed, and you're scaling, you're giving the horsepower which is required for your piece of code because you understand the volume well. And that's it. We are now taking this information, right, and wrapping it in a stored procedure. This will take a couple of more minutes for this to get executed. By the meantime, we'll look into the other part as well, right? Which is nothing but the daily city metrics as well. So we'll understand what this piece of code is doing. Okay, this is nothing but if we go back to the other slide, this is we have done with the stored procedure order, and we are running this which is populating. Now we want to populate this table called as daily city metrics, which will be used by downstream developers. To populate that, I need a stored procedure which is using a Python code and joining across multiple sources. It could be the weather, it is from raw data, and whatnot. It is from the orders as well, order string information. So when you look into this particular piece of code, it's doing very much similar to what we have seen, right? It is creating create daily city metrics table, and we are calling the merge. So let's see what these two functions are. So first one is create daily city metrics. So first thing is most commonly used pattern is creating an empty data frame, right, with set of columns. So how do we do it in Snowpark is basically we define a structure. What is the column and what is the type of the column for my data frame to have. So basically that's what we are doing. So we are giving the column names, the shared column names, which is nothing but the structure what I'm defining. And then I create a data frame. I see session.create data frame, none into length. So it knows that I need to create a row, which is an empty row with set of n columns. The n columns is given by the length. And I define the schema. The schema is nothing but I'm defining it over here. So I added some columns, and eventually I'm adding more columns to a list. Specifically, you are adding more fields, which are nothing but columns again for a data frame, right? So in this case, it is just creating an empty data frame, right? I'm creating an empty data frame and writing it to analytics daily city metrics. So this is pretty much an empty table what you can create, right? Once you have this empty created, the next step is how do I populate this information? This is where your merge daily runs. So looks like, I'm sorry, I'll just go back and showcase the orders table. Looks like this is done. Yeah, so this is the order table what it has created when I'm running that particular code. So you have seen the code. When you run the code, even you have the details about it has got close to about 1.8 billion rows. The size of this table is close to 51 GB. Right, so we have the data what it has created, and next let's look into the or else what we'll do is just in the interest of time, probably since we have like 15 more minutes, I'll quickly create the other one as well, so that we are not wasting our time. The way we have done this stored procedure, I will create one more stored procedure, which is part of our, which is nothing but the daily city metric that we are looking into. We'll deep dive onto the code part, but just to save some time, let me create and run it. So this will go ahead and create a stored procedure with this name, daily city metrics update, and it would be part of my analytics schema. So we'll quickly see once it creates, it takes a few seconds, and once it gets completed, we'll go ahead and we'll see the structure of that particular stored procedure. So this is the stored procedure what was created, and as you can see, it's the same thing. All it's doing is just executing the Python code, which is doing various transformations within that code. Now let's go ahead and run. If you want, we have seen the snow way. Now let's run it in snow side. Okay, this will take some time for the code to get executed. Okay, let's come back to the actual code. As you're seeing, we are just joining multiple tables. Also, we'll see how do we invoke any custom functions, right? As you can see, we are calling a built-in function and invoking a function 0 if null and all. So we can invoke the way we have created. If you have a custom Python code created, function created, you can invoke that using just call built-in and pass this information. Also, you can any existing function that you see in Snowflake, which is not available in Snowpark function, you can always use that by just calling call built-in and give the name of Snowflake system function and pass in the argument that function takes. So this is taking like the order stream what we have, and this is how it's taking the weather data, which is coming from the marketplace. As you can see, we are just using session.table. Since it's a read-only copy, it gives you the information what is needed from that live table, which you got it as part of data sharing. Right, so same is with, I'm taking country information, doing joining across data frames, typical, right, data frame joins or pandas data frame. I can do aggregations, group by, average, min, max, and even this is the one what we have created as a first step, right? You could see a Fahrenheit to Celsius. We have created this function. So in fact, I'm calling that function call underscore UDF. I'm invoking that function and passing the value. Since it accepts an integer, I'm giving one of the column values as an input to this function and aliasing it to the name what I need. So it's how you can mix and match, right? You can the same function, you can use it as part of your SQL statement. Same function you can even use as a part of your data frame APIs. Few other average, min, max, typical aggregations, what you already are aware of, what different aggregations you can work. And then again, I'm joining the orders table that we have seen as part of the previous step, how the 1.8 billion record stuff and all. We are just joining with this weather information, which is coming from marketplace. The marketplace data, we are using our function, the custom Python function, what we have created, that we are calling it against the marketplace data set. So it's basically the combination, right? That's the beauty. You're able to join different data sets coming from different places and using your own function, what you write. And pretty much. And again, all we are doing is using the same merge, right? Columns to update if I'm joining on date, city name and city name. So these two data sets are joined on date and city name. If a match exists, update the columns. If it does not exist, insert, right? You can make your merge more complex, framework driven and whatnot, right? You should have a common framework which might be doing the merge. You can use these commands to do that. And similarly, we are just scaling up. As you could see, when the job starts, we would say increase the size of the warehouse to extra large. And once my transformation completes, I can set it back to extra small so that I'm preserving or I'm saving the credits and it's not consuming since because it's pay per second and you don't have to pay when you're not actually using it, right? So you're reducing the size of the warehouse. So this is, and probably it's taking some time. Yeah, so once these two are done, right, now the next question is the orchestration. How do we orchestrate? So I have all my objects, all the stored procedures created. That is where I need to orchestrate. So as I said, we have something called as tasks, natively orchestration feature that helps you to run any stored procedure, a select statement, or a piece of code block you want to run it. It helps you to run these within a task and you can schedule it. Now, what we are doing is once you look into this task, right? I'm saying I create a task. It even helps you to change the series of tasks. I have a task A which involves which populates a table 1. Then I have another task which populates table 2, but table 2 has to be populated after table 1. So I can create this DAG where it says one task needs to be executed on the other task. So for that, I created an order update task, and it's saying if the stream has data, as we have seen the stream, if there's any new data coming into that stream, only then call this, or else you don't have to call it. And this same thing is for order stream. There's one more task, and but important thing is over here, the after clause. So I'm saying execute this particular task after this first task is executed. So that's how we are chaining or creating a DAG where we say a task would be executed after the other task and all, right? So if I look into here, I wouldn't execute, but just to showcase how it looks like. Since it's a SQL, right? I can go ahead and just run these. So it's executing all the commands which are over here. Yeah, so it's done, and we'll see where it has created. It has created in the task in the analytics harmonized schema. Let's go ahead and see. Okay, even daily city metrics got populated as well. Good for us. So I can see the definition, or let me show you the DAG that I was talking about. So if I look into the graph, right, so it gives me this DAG. It says, okay, daily city metrics needs to be executed only after order suspended. Now, we haven't given any schedule for this because we want to manually run this particular task. You can just go ahead and, since I've already commented this out, all you have to do is do an execute task and that's it. Whatever transformation that you're doing in this step, and eventually on next once, as soon as this completes, this will be triggered because we have set this particular task needs to be executed only when its previous task is completed. So that's where you get to see in this statement after a specific task execution. So you can specify those clauses that helps you to create a DAG and ensure your tasks are executed one after the other. Even you can look into the run history. If there are, as you can see, like you have failed, run it multiple times, you get an history of when these tasks are executed. You can run alerts and whatnot. So you've seen the cycle. You've created a lot of objects. You've created stored procedure to populate. These stored procedures are your data engineering pipelines. You have seen how do you execute, orchestrate these pipelines, data engineering pipelines with using tasks. And last step is we'll see how do we deploy these objects, right? So as you can see, I have this code everywhere. I have code as part of my GitHub. And if I look into the settings, few things is we have to set the credentials, right? Secrets and variables. And this is where you specify, okay, what is to which account you want your object, specifically the Snowpark, right? Python and the Snowflake objects, what you're creating, where exactly you want to deploy it. Now we are using Snow CLI. you'll get to see over here. Right, this is my build and deploy YAML file. Right, I'm taking the credentials which will be part of my secrets, and eventually I'm using Snow CLI, creating a GitHub workspace, and using Snow CLI to deploy. So the code which I'm using to deploy all my to be say artifacts to be more precise, or the objects is to GitHub is basically over here. Right, if I see, this is a custom code what you have written, and it's using the CLI. The way we have run it, right, Snow, I say function create, Snow procedure create. So I was just showing you through the command line. The same thing is getting executed using GitHub action. So anything that gets checked into the main branch, this will be triggered, and your objects would be updated accordingly. Right? We'll see how exactly an example over here. I would change this to this. I say I'm using SkyPy, and let's first validate this is working fine. Okay, good. So I see some results. So I'm comfortable, and I'm sure that this is what I need, and I want to deploy it. So I'll go to my GitHub. This is orchestration system. Let me save this. This one, I'll just change it to something else, I guess. Yeah, looks like this is the change what it needs. Okay, so I'm just taking whatever changes I need, and I'm ensuring this is what I need part of my code. Now I'll say changes. This has got few steps, and I want to commit. So we are actually updating one of these stored procedures, right? The stored procedure is let's go back to, let me show you what stored procedure, right? So as you can see, the name of the stored procedure is the Fahrenheit to Celsius, right? You should see this getting updated, and this is what, let me zoom it. So this is how it getting, so this is invoked. Since we have made certain changes behind the scene, this will take probably like 2 to 3 minutes, or 3 to 4 minutes, as you could see on an average, it took 2 to 3 minutes. So taking the changes, whatever is there in our local repository, we are making the changes, pushing. I am not creating anything on the server, only the Python code where I need to make changes. I'm just making those changes, pushing it to my main branch, and behind the scenes, this I'm pushing it to the main. You can have pull request, all those checks and balances in place, right? So once it's part of your pull request, you see everything is good. Merge it with the main branch, and it gets invoked automatically. That's how we define. You can change it where you say don't invoke it. You want to run it by yourself. You can pretty much do that. So these changes are getting deployed onto the Snowflake account. So when we look into the deck, so we have covered all these aspects, right? We have seen how do we create Snowpark specific objects. To be more precise, how do I create Python stored procedure? How do I orchestrate that? And how do I deploy it across different? And we have seen in a single Python file, you're running your entire data engineering pipeline, wrapping in a stored procedure, deploying it to different accounts so that it is productionized and handled well. So that's pretty much I wanted to cover. Probably I'll open up for some questions, and that's it from my side.
So funny.
Please, Salita.
Yeah, Farhan. Just a couple of questions. Just one, most probably. It's like, what about the performance if we are converting, if we are converting the Python to SQL, does the performance get impacted? Is one of the questions. And the second is, how do we test the data or deploy the data with CI/CD? These are the two questions. Funny.
So deploying the data, you can use different way, right? If you can integrate with DVTs and you can have that. This specific pipeline I wanted to showcase specifically for Snowpark use cases, but for data and specific to like tables and which is not Snowpark, you can have we have a quick start for that. Probably will share that, which helps you to identify how do you deploy objects, use DBT to populate data and whatnot as part of your pipeline.
Yeah, and the second question was around any performance, challenges because we are pushing down.
Yeah, we have not seen where our Snowpark data frame got converted to SQL command, which is really bad. We haven't come across that scenario. But if you are really writing an optimized SQL, you might see that some of the queries are different from what you have written because it creates a gigantic queries. Some users might not feel it is optimized, but yeah, we haven't seen any significant difference in terms of the performance between the code, native data frame code versus the SQL code, what it is generated.
Yeah.
I see.
Some of the questions I have also answered that since this is lazy evaluation. So what happens is that your code keeps on getting translated or transformed. And then once you are actually executing the same, the code exactly runs just like the other code which you would have done on Python. So that also helps in not having a performance upside. So there have been some questions around the pandas data frame and also, machine learning code. Can we also send machine learning code to Snowflake servers? And
yeah, exactly. You can perform your model training inside a store. Let's say you're using any scikit-learn packages for linear or logistic regression, right? You can write that Python code, wrap it in the stored procedure. You have different warehouses to support machine learning. It's something called a Snowpark optimized warehouse. So that helps you to, because that's a beast box where you get a lot of mem and CPU as compared to the standard warehouse. So whenever you're running a machine learning workflow, ensure that you're using the Snowpark optimized warehouse that provides more resources and better performance, specifically for machine learning or wherever you need Panda specific, where you're getting gigs of data. For in those scenarios, Snowpark optimized is a good option to pick.
Yeah, Anil has a question which he wants badly to be answered, which is, can I get the answer for my questions? Sometimes we have to convert the Snowpark data frame to Pandas data frame for feeding it into machine learning algorithm. How can it be handled in Snowpark?
Yeah, so basically that's pretty much for now it is, but yeah, they're work in progress where these especially some of the scikit-learns would even accept Snowpark data frames as well, but nothing concrete yet. But you would see something good work happening on that side as well.
Ranjit has a question around, can a ML model output differ? Give different results when the iteration with data set varies? If yes, how do we ensure that it is all consistent results after all these iterations? So anything funny which you think about? Otherwise, I'll just have my 2 words.
Yeah, go ahead.
Yeah. So, hi Ranjit. So for this one, right, the ML model, whether it outputs, different results at different iteration sets. So usually the data sets are divided into training and, the inference part of the data set. And if your data set changes, your output could also change, which is applicable across the board. It is just not Snowflake, right? And also, how do we ensure that we get consistent results? See, what is your conversion mechanism or what is the algorithm that we are using under it, whether it is sigmoid or linear or any of the other algorithms which we use? They actually define how our ML processing happens from one activation series to the other, right? So we have to control there, and then we will be able to get consistent results, and that part of testing as far as ML learning goes. Yeah, I hope I could answer your question, Ranjit. There were a couple of questions around tasks and streams and everything. So I have given the links. I have also provided the links for this particular session, which
Funny was covering, that particular quick start guide. So there you can find all your coding and all the code snippets and everything, just like Funny mentioned. Any other question, Funny, which you find interesting, you want to go for, otherwise over to Farhan and Funny.
Sure. Some of the questions inside stored procedures, performance, what is the difference of Python code inside stored procedure as compared to UDF? No, this is nothing to do with Python versus stored procedure versus Python. It's the use case that you're looking into, right? UDF gives you a scalar. You need a scalar output. You would use UDF, right? Stored procedure will not help in that scenario. So that's the difference at all. Can you share a link explaining wrapping Python script? Yeah, probably this one will be shared after. In fact, the quick start has a lot of details about it. Session.table, this is nothing but you can give any variable underscore session.table. This has nothing. We are just saying we don't want to use any variable. You can give ABC as well. It doesn't matter. This is for Abhishek.
Right. Funny, I think we are right on time. We have another session coming up. Data processing. There are a bunch of questions on streaming data. I think in the next session where we have Ritabrata Saha taking you through a journey on streaming data on Snowflake. Most of your questions will be answered. Once again, thank you so much, Fani, for joining today's discussion. Sarita, thank you so much for being an ace on the Q&A. Thank you so much, everyone, for being on the call. And I'll see you all back on Zoom in another 10 minutes. In the meantime, grab yourselves a cup of coffee. And thank you so much. Have a good one.
Thanks, all.